So while you guys are getting your packets out, just to quickly review, there's three shortcuts that we can use to prove triangles similar, and they're called the triangle similarity conditions. By the way, do we remember what similar means? Similar figures have same shape, but maybe different size. Actually, if they're the exact same shape and the same size, they're still similar. But there's something more than that. What do we call two figures that have the same shape and the same size? Starts with a C. Congruent. Those are congruent. All right, so we're focusing on similarity, but we'll see congruence come up in one of our proofs today. So we've got angle, angle. That's if you've got two angles in each of your triangles, and they have to match. So either you got to have the same number for both of them, or remember, you can also mark angles congruent with some arcs and ticks like that. SAS stands for side angle side. So you've got to have two sets of sides and a set of angles. The angles have to be congruent and they have to be touching both sets of sides. Remember, when you do ratios for the sides, when you divide them, you got to come up with the same value for both of those ratios. That means they're in proportion. And then side, 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 you've got to have information about all three sides in both triangles. You got to be able to match them up and create the same value for each of those ratios too. All right. So that said, let's have a look at this first problem here. Can you guys see that okay? You got it on your page in front of you. Did you get a handout? Yeah. Anybody else missing the handout? All right, so I want you to look at these two pictures, and our goal is to figure out what similarity condition we can use to prove the two triangles similar. What do you think? Pencil sharp. There is no pencil sharpener in our rooms yet, so I do not. Does anybody have a handheld pencil sharpener? Jackson can borrow. You're okay? All right. Sorry. Hopefully we'll get those soon. It's on our list. All right. Similarity condition. You're looking at this picture. What do you think? Any ideas? Angle, angle. So I've got one set of angles. Remember the AA, you got to have two sets of angles. For each of these similarity conditions, each letter represents two things, one thing in each triangle. So I'd say we've got an A here, but we don't have another angle just yet. We do have two pairs of sides also. Is the angle touching both of those pairs of sides? Yeah, now we would have to make sure that those sides were in proportion. Are they in proportion? Let's set up a couple ratios. I'm going to do the big number on the top and the smaller on the bottom. What would the 16 match up with in my other triangle? 16 would match up with 8. What's 16 over 8? 2. And we've also got a side of 6. What does it match up with? It matches up with 3. And 6 over 3 is also 2. So we've got the same ratio. So here's our two sides. And here's our pair of angles. All right, so we said we were going to use side angle side. So let's practice making a flow chart. So if we're going to use side angle side, we need 3 bubbles. We need a bubble for each of the letters in our reason here. So I'm just going to go ahead and make 3 bubbles going across here. So some space. So 2 of those bubbles are going to be for sides and one's going to be for angle. And it doesn't matter what order you put them in. Some people like to do my sides here and the angle in the middle because it matches the order here, but it doesn't have to be that way. I usually do my 2 sides and then I do my angle separately. That's how I'm going to set mine up, but you can mix and match. So I'm going to do one of my sides here. Do you guys remember what the bubbles look like, the evidence bubbles look like for sides? There's 2 fractions and an equal sign. in your first fraction, you need to name the two sides that match up. So let's go ahead and use the 16 and the 8 since we've already kind of set that up. What was the name of the side with a length of 16? What could you call it? We named sides by the points on both ends of it. So M and L. Okay, so we're going to go ML. That was the 16. And what would the side length of 8 be called? BC. So ML over BC. So that first fraction, we name the two sides. The second fraction, we're going to put the lengths of the two sides to create a numerical ratio, which we already wrote down, 16 and 8. And then after that, we just have to simplify it. Sometimes this isn't going to come out to a whole number. Sometimes it'll be a decimal, or you could do it as a reduced fraction. So that's one of our sides. So check. Could you guys right now go ahead and use that as a model and write me your second bubble for side, and we'll do the angle last. And write that second bubble for side. Thank you. You too. You remember. Yes. So we're looking for, sorry. Good. You want to keep them organized, right? I like it. So we want to match in this one. We get our bigger number on the top and smaller number on the bottom. We want to be consistent. Oh no, I'm sorry, I misunderstood. Yeah, BC and CB are the exact same thing. You got it? All right, so let's use our other ratio. So 6 matches up with 3, right? Go ahead and put 6 and 3 in that second fraction. Now look at what is, yeah. You got it. And the top would be, yes, you got it. Nope. No, we're going to do an angle for that one. All right, looks like we're coming along. Oh, I'm impressed. My last geometry class yesterday was way rustier than you guys. So cool. All right, so we use 6 and 3. Sometimes my students find it easier to write the numbers in first and then go back and name them afterwards. So KL, and great question came up. Is there a difference between KL and LK when we're talking about a side? There's no difference. So if you wrote L instead of KL, that's fine. That's totally fine. You do want the 6 on the top, though. Why would I not want the 3 on the top here? Why would I not want that?
Because you need to have, because this, not fractions, but the, what's it called? So you need to set up the same way. So the bigger numbers on top of those.
Yeah.
Smaller numbers on top of those.
You got it. Yeah, we need to set them up the same way, right? If I chose the bigger number on top here, then I need to be consistent and do the same thing here. All right, so KL, and then 3 was, what was that? Did you guys do BA or AB? BA, AB. I'm going to go AB. I'm kind of in the habit of putting my letters in alphabetic order when I have a chance, although I didn't do that here. And we said that came out to 2. All right, so that's what our side bubbles look like. Now the third bubble is going to look different because it's an angle bubble. So we've got our 2 sides, and then we just need to do our angle bubble. And the angle bubbles are easy because you just need to name the 2 angles. Remember, there's a little angle symbol that goes in front. And we have to show that they're the same as each other, that they're congruent. Now, we don't put a number in here. We're just going to name the angle. Name the angle with either a single letter or 3 letters. 3 letters is always safe, but we can get away with a single letter if there's only one angle there. So I'm going to go single letter for this. So this one is angle B. And the one that was equal to it was angle L. So we've got our 2 sides here, and we just got our angle. So side, angle, side. So that's all the evidence that we need. And what was it we were trying to prove here? That the triangles are similar. So we now need our conclusion bubble because we've given all the evidence. It's time to give our verdict. And our verdict is that we have two triangles that are similar. I'm going to call the first one ABC. And I'd like you to match them up. Remember, you got to get them in the right order. You can call the first triangle whatever you want, but the second one has to match the correct order. So since I chose to put A first here, what do I need to put first in my other triangle? What matches up with A? K matches up with A. So I chose to put B first here. B matches up with L. I chose to put C here. C was last. That matches up with M. All right, is this kind of coming back, guys? We're not quite done. I'm missing a couple of things. If this were on a test, I'd be missing a couple small detail kind of points. I got like 8 out of 10 points. Give me one thing I'm missing. I heard it back there. Say louder. Arrows. Arrows must go from the evidence to the conclusion. They have to have an arrowhead on them. So I need an arrowhead going into that bubble from each of those. There's one other thing that I'm missing here. There's something that we put when we give a reason for our conclusion, and it goes in this spot right here. What is it?
I can't remember what it's called, but
What should I write though? Okay.
I have it in my mind. when I said it.
Anybody want to weigh in? What do you think?
You have to put similarity conditions.
You got it. Yeah. So the reason we were able to do this is because we had side angle side. So our reason is SAS, similarity.
Also need to what's it called here? Not just- Also need to be like circle or box.
No, usually these are not. That's why I kind of made a dashed line around it. Usually we do not put our reason inside of a circle or anything. And this is convention. The convention is that this ends up going kind of down and to the right from it. You need it kind of close there so that you know which one it's attached to. Great. Give me a second, please. Okay, are we feeling pretty good about these? On a scale from 1 to 5, how comfortable would you feel building a proof like this from scratch? Stay on a test, say next Friday. On a scale from 1 to 5. Okay, I'm seeing quite a range. 2s, 3s, 4s, 5s. All right, let me ask you this. What if I gave you the flow chart, and the flow chart already had the bubbles, and I left out this and this and this, and I left out this and this, and I left out this and this, and I left out this and this. Would you be able to fill in those blanks? If I gave you everything and I set it all up for you, and half of it was filled in, and you just had to fill in those missing pieces that I just put boxes around. On a scale from 1 to 5, how would you feel about doing that on a test next Friday? Oh yeah, they would have the picture and everything too. Would you feel pretty good about that? All right, because that's how I'm going to test you on this. Okay, I don't expect you guys to be really great at putting together proofs from scratch. We're going to be doing proofs for the whole second semester. By the time we take our chapter 4 or chapter 5 test, you will be building proofs from scratch. But But for now, we'll kind of give you a template for it, and you just have to fill in the blanks. So as long as you're feeling confident about that. Now, that said, I am going to now challenge you to build some of your own proofs from scratch, but I'm here to help, and you've got your people around you too. So I want you to look at the bottom of the page. There's 6 triangles here, and every one of these triangles is similar to another one of the triangles. Okay. So, but I don't tell you which 2 are similar. So like maybe these 2 are similar and these 2 are similar and these 2 are similar. I don't know. All right. So one of the things you got to figure out is which pairs are similar. Now, once you do that, I want you to go to your notebook and I want you to make a proof for one of those pairs of triangles. So let's say you decide that these 2 are similar. Okay. I want you to write a proof for those 2 in your notebook. Now, we just did a side angle side proof. When you're choosing which one to do, I want you to make a smart learning decision about this, right? If you're feeling pretty good about that side angle side proof, then I would maybe try one of the other ones, because spoiler alert, there's an angle, there's a side angle side, and there's a side in here, okay? So if you're feeling pretty good about this, then when you get down here and you figure out which ones are similar to each other, maybe go for something different than what you just practiced. However, if this was a bit of a struggle for you, then maybe you want to pick the side angle side so you can develop some more confidence with it. All right, I'm going to give you about 15 minutes to work on this. If you finish one proof, I challenge you to make a second. And if you finish the second, I challenge you to make all 3. Okay, some of you are going to have time to make all 3 proofs. Please get my attention if you've got questions. When you finish your proofs, get my attention so I can check them over for you. While you're working, I'll be wandering around. And then we're going to come back together and talk about one thing on the back, and you'll have some time to start on homework today. So, I should note one thing really quickly. I did not say this. Yes, I did say this. It's written right here. What does this mean when I say a drawing is not to scale? It doesn't look right. Yeah, it may not look right. For example, if you look at this triangle right here, your paper says that this is a 3 and this is a 3. Do those sides look like they're the same length? No, they do not. But are they the same length in terms of your proof? Yes, they are. Okay, so you've got to go based on the numbers, not on what you see. Same thing for the shape. So you might find 2 triangles that don't look similar. They don't look like they're the same shape, but the numbers tell you that they are. Okay, the numbers meaning when you set up your ratios and you find your angles, it all matches up. All right. Any questions about your task here for the next 15, 20 minutes? All right, get after it, folks. I'll be around to support you here in a minute. Yes. All right, so did you find that there was a side, a side angle side, and an angle in there? All right, for your side, did you write a proof that had 3 bubbles that looked like this? And they all had the same number at the end? Okay, and you wrote SSS similarity down here. For your angle, did you write a proof that only had 2 bubbles and both of those bubbles looked like this? There was an angle, yeah. So we had to do a little bit of reasoning here, but because right, we've got this 90 degrees here that matches this 90 degrees here. You did angle. Okay, so angle exists, but we don't usually use it. So when you have a situation where you've got 3 sets of angles, right? Because if you work to figure out, you can figure out what this angle is, right? They add up to 180. So do a little subtraction. This comes out to be 36. This comes out to be 54. And yes, you do have angle. And in that situation, just pick 2 of them, any 2 of them. So everybody's proof might be a little bit different. So you should have just 2 bubbles that look like this, and then angle similarity for that one. And then obviously your side angle side would look very similar to this. All right, let's flip over on the back. And I apologize, I kind of copied this weird. You got to flip it and spin it. All right, I just want to talk about this first question here, 96A. From those problems that you just did, which pair of triangles were congruent? We had 3 pairs of triangles that were similar, but there was 1 pair that was congruent. I'm gonna see if I'm calling someone else because I know you know the answer. We talked about it. Thank you. Which pair was congruent?
The side angle side.
The side angle sides, these 2 here. Now they don't look like they're the same size or the same shape, right? Congruent means same size and same shape. But what was it about your proof that told you that they were definitely congruent?
Because the fraction went to 1.
Yeah, good. So when you matched up the 5 with the 5 and you wrote that ratio, it equaled to 1. So if you end up with a ratio that's equal to 1, that means not only are you similar, but you're also congruent. So on your test, there's going to be a couple questions where I give you a pair of triangles, and it's 2 questions. Are they similar and are they congruent? You just circle yes or no for each of them. Now, if they're congruent, do they have to be similar? Because congruent means what? Same size and same shape, right? And similar. Pause for a moment. I'll tell you what, flip back over on that back side. Let's say this. I feel like you guys got some good practice. Everybody, I'll give this back. Everybody did a nice job on those proofs. If I didn't get a chance to look yours over and you want me to come around and give you feedback, I'll do that. In your packet, could you guys open up your packets? On the back of the first page, I guess that would be the second page. You've got a learning log for dilations, and hopefully you put some notes into. There's one down below for flow charts. Do you see that? So now that you're feeling kind of comfortable making flow charts, it might be a good time for you right now to take 5 minutes and get some notes in there. Me personally, if I were going to be taking this test next Friday, I would probably put at least 1 example down. We did that example together at the beginning of class. You know that one's perfect, so that wouldn't be a bad choice. I might also kind of make some notes to myself about what the different flowcharts look like, right? Side, side, side have 3 side bubbles. And what does a side bubble look like? An angle just has 2 evidence bubbles. They're angle bubbles. What do an angle bubble look like? So I recommend right now, before you start on your homework, that you spend a moment and just get some information down in your learning log for flowcharts. I'll put the entire homework packet up on the screen in just a second when I can reconnect, but I'll write it up on the whiteboard here. We're going to be doing section 3.2.5. You can go ahead and add this to your stamp sheet if you like. Problems 99 to 104. So with our remaining 15 or so minutes, I'd like you guys to, number 1, make some good notes on flowcharts in your packets. Number 2, get my attention if you've got questions over any of the flowcharts that you just created for yourself. And then number 3, go ahead and start on that homework assignment. Books are right up here on the bookshelf if you need to grab one. You're welcome to use your computer as well. All right, see if I can get this back up on the screen.